because then you would just like, and as you change the angle of the camera, you've never seen this before with like mirrors and things like that? Yeah, you can like make it infinitely bounce back and forth. It does that, but instead of bouncing, it's going through itself. So it's kind of crazy. But all right, today is the 20th of June. Can't believe it already. More than halfway through June. So we can go back to any previous chapters if necessary, but we'd like to start with focus on 7, since that should have been what we were working on this past week. So what questions are there from chapter 7? Target 7-1. What practice forms did we do this chapter? Did we do G's or K's? G's. 7-2. I know these chapters are slightly easier. I might just pop over here on the school and look at this. 7-3. Oh yeah, this was geometry. This is why no one's asking questions. 7-4, about angles, getting angle pairs. This is where it gets a little tricky, so please don't be afraid to ask questions with the angles or angle pairs work. 7-5, specifically angle pairs. 7-6. This is where people normally have questions. Distance formula. Everybody's good on distance formula, how we find distance on the coordinate plane. Thank you.
Can you do number 24?
I'd love to. Is this the right homework? You guys said we had G forms?
Yeah.
Sweet. So which question?
24.
24. So we're trying to figure out the length and width of the table. Now what's nice about this is because I see that the table's square, I have the same rise and run for each of them, I will know that the length and width are going to both be the same. So I'm going to take all of this actually and throw it into Smart so I can work with it. So we have a 14 by 10 foot room. We're going to find the dimensions of each piece of furniture. And what do we know? We have some labelings on our X and Y axes. That's our 14 by 10. So what is our general distance formula? So when we talk about distance of things, it's really a manipulation of the Pythagorean, right? So our Pythagorean is a squared plus b squared equals that c squared. Well, our distance is like that c, but we don't want it to be squared, so that's why we use the square root of. If it's like that a squared plus b squared, what are we doing?
X1 plus X2 plus squared plus Y1 plus X2 or Y2 squared.
So we really are setting up a right triangle. So if you want to visually represent this, because the distance formula for some people is really tough when we just talk about the formula. This is just a right triangle, and we're just setting up a formula to solve the hypotenuse. So if you don't like the distance formula, don't use it. Use a different form of it. You are more than welcome to start with c squared equals a squared plus b squared. And you are more than welcome to then make that c equals square root of. I think here we plugged in the wrong things, Cassie. Just maybe. I think this is x2 minus x1. I think we're finding the distance.
Oh, okay.
So these are actually the, it's not the sum, but it's the difference. So just be careful there. Because if you're given, so that's like when you're working with coordinates. So if you were given coordinate geometry and you're like, find the distance between 2, 3, and 7, 8, then you can do the subtractions there, so be careful. That's actually a difference. But it's easier if we set it up like a right triangle. So until you get comfortable with distance formula and what you're doing, think about any diagonal distance as a right triangle. What's my A? What's my B? Well, here I have an isosceles, so I really just have 2 squared, 2 squared. So I'm going to get 4 and 4, so I'm really going to get that C is a radical 8. And if I want to simplify this, I can make it radical 4 times 2. And then the radical 4 can reduce out, and I get 2 radical 2. Radical 2 is approximately 1.4. So I could try to get this out into a decimal form. I could just leave it 2 radical 2. And whatever distance, I think it was feet. Yeah, so that'd be 2 radical 2 feet. So just put apostrophe if you will. So let's approach it the other way, actually. If we were doing it the coordinate geometry way, just to make sure that distance formula is comfortable. Because let's review what the distance formula actually is. Because we wrote it up there kind of off that one point. So we actually don't need that. Let's just take this. And let's do the bed. Let's do 25 and do some coordinate geometry. So we're going to do length and width of the bed, but instead of doing, we're going to imagine that we actually don't have it and we're not going to work with that. So let's just pick 2 points. So if I want to talk about the width, that uses points 5, 10, and 9, 6. So where our distance formula comes in here, and if you're not comfortable with this yet, I would write it out again just for your own getting it in your brain. It doesn't matter whether you do your y's or your x's first, because we're going to add them in addition's commutative, but it's your y2 minus your y1, which really means what's the difference in the y's. x2 minus the x1. Each one of those is squared. So this distance in the y's, well, 10 to 6 is really a distance of 4. Positive and negative doesn't matter here. So although I could do 6 minus 10 and I get a negative 4, all that we care about is that we get a 4. So if you want to do the 6 minus the 10, you get negative, but when we square it, it becomes positive. That negative doesn't matter. The x2 minus x1, well, 9 minus 5 would give me 4, so that actually would be a positive 4. And 4 squared is 16, plus another 16. And we would get that the width of the bed is a radical 32, which we could actually write as radical 16 times 2. Radical 16 can be evaluated and simplified out to just 4. And we get 4 radical 2. We can do the same thing over again, except instead of doing width, let's do length. Let's do one that involves a 0. That would be a good example. So if we do one that's on the axis, so let's go from 0, 5 to that point 5, 10 that we had. So again, set up that your distance formula, square root, y2 minus y1 squared, x2 minus x1 squared. plug in. I'll write out the whole process this time. 10 minus 5. 5 minus 0. 5 squared. 5 squared. And we're going to get square root of, well, each 5 squared is 25. So we get 50. Or we can simply say one of those 25s could have worked out to be 5 radical 5. Please do not fall into the trap of thinking that you can say that both of the square roots of the square cancels out. That does not work. That only works once we set them up in multiplication. So that in between that has to happen right here is that this is square root of 25 times 2. Sorry, this is not 5 radical 5, it's 5 radical 2. That's what happens when you start working too fast. Because you can only break it up and take one piece out once you get it into the multiplication. So then you can pull one of them out. Questions on any of the homework left, or any of chapter 7 left, because that's really the end of it. Nothing else from our Tools of Geometry chapter, or the quizzes, or the practice tests. I got a lot of stuff up here that you guys were able to be working on. If you're able to do that practice test, you're ready for the test. All right, well, let's just move on to chapter 8 then. Take any questions from that. Geometric transformations. Thank you, especially to Lucy. There's a couple videos in the Help Me folder. Sorry, that's the discussion. In the Help Me folder, there's a couple new videos here showing a couple questions on the practice test. The practice test is a really good idea if you want to see, are you ready for the real test? And if you guys have questions, please ask. Lucy shot me a text, and I was like out of town or whatever else. And as soon as I got back to school, I just made a little Chalk Talk video with some graph paper, and yeah, just talked through it all. So please ask me questions as you come to stuff like that. But questions from 8.1 on translations. 8.1 on translations. Moving up or down, left or right, or a combination. Reflections. 8.2, reflecting across a given line, either an axis or a horizontal or vertical, or, if you get crazy, across a diagonal line. Couple of my images, I guess, are dead. 8.3, rotations. This is where people start to kind of have some struggles. So I don't like saying memorize tables, but a lot of times people screw up trying to think about these 90-degree rotations, whether it's 90 degrees counterclockwise or 90 degrees clockwise. Be careful. Positive rotations in the coordinate plane go what direction? Counterclockwise. A positive rotation goes this way. So when they say rotate 90 degrees, if you are in quadrant 1, you're going to quadrant 2 over here. That's 90 degrees. So everyone gets goofed up because clockwise. It's actually counterclockwise to do a positive geometric rotation. Questions from this section, 8.3? 8.4, composing those. And isometry is when you do something like a translation, a rotation, a reflection, so you compose them, put them together. Any questions from any of 8? Chapter test, quizzes, any of that? Alright, I don't know if this is because we're not there yet or if these chapters are just easier. Any questions from anything? Chapter 5, chapter 6, Ellie?
Why do you go downward that way when you're on a graph? Why is it positive that way and not positive this way?
You could research it, but I'm not actually quite certain at the point, like right now. I don't know why we decided. I can Google it if you want.
Okay.
Why
We
is
were
a
talking about it, so
positive
at least it wasn't about
rotation
yeah, it sucks.
anti-clockwise? Ooh. It's not how, it's why.
Yeah.
Oh, I can go back, but I have to move my little recorder screen. Physics one. Yeah, see, this is what I was suspecting. The only reason that clockwise is because somebody decided to make that way. I would bet it goes back to whatever, like, models people started to use, the rotation of things were going, like, anti-clockwise or the positive geometric rotation. Yeah, and that became your positive rotations, and then for some reason when we made a clock, we decided to count, because we read left to right, we wanted the numbers to go left to right, and then that became a positive clockwise rotation. But that doesn't like mean anything for positive rotations. The reason mathematically that it makes sense for us to do this with positive rotations that direction is because if I draw a coordinate plane, we know this is your first quadrant, right? Top right. Everyone knows that. But why? What are the x and y values there? All positive. So that's our first one, because we have positive, positive. Where's our second quadrant? Top left. What are the characteristics there? Negative, positive. Then, my third quadrant is negative, negative. And my fourth quadrant is positive, negative. Now, have you guys learned much about unit circle yet? Anything about unit circle? So, okay, let's blow your mind. So, you guys know some circle rules, right? And I'll stop whenever you want to stop. And you guys can really come grab tests or whatever you want, because this is beyond what we're doing today. But this is just knowledge to be dropped on you. So, the unit circle is something that you'll come to know and love here in your future mathematical career, and I'm going to cheat. Sorry. Perfect circle. Really, I'm not that sorry. So, when we start rotating on a circle, we call this point in our unit circle point 1, 0. So it's literally on the coordinate plane. That circle is centered at your origin. When we rotate and we go the entire distance of the circle, and we talk about circumference, how do we calculate circumference? Crust equals pi dough, right? You guys have never heard that? Crust equals pi dough. Circumference is pi times diameter. Crust equals pi dough. Please put that in your head so that you can remember circumference in the future. So, pi times diameter, well, if this is at 0.10, then what is the radius of my circle? 1, which means my diameter is 2, which means my circumference here is 2 pi. This unit circle then can be broken up. Well, if I know that that distance traveled was 2 pi, then this distance traveled from here just around to this point would only be a single pi. So you can't see that very well. And this distance traveled up to here would be, well, pi divided by 2, or a half pi. And we start to break this up into pieces. And this is where the fundamentals of trigonometry come from. It's the relationships between those points and triangles that we can make, because then we get to points, like let's say a 45 degree, which that's not really a perfect 45 degree. What would we know about the legs of that triangle if this is a 45 degree? If it's a 45 degree right triangle. I know it's summer and we don't like to participate in it. What would the other angle be? 45, right? Which means that the legs will both be some length. Call it z. We know it's less than 1. But what we know is the hypotenuse itself is 1, because it's a radius. So this is way further than you need to know right now, because you got to learn Math 1 before you can learn the unit circle Math 2 stuff. But this is when we start dealing with trigonometry. The unit circle is where it all comes back to. And hopefully you have a decent Math 2 teacher who really helps you understand the unit circle, not just like memorize it. Because you'll end up filling in a unit circle with like, where are the points around it and their pi values. And it seems complicated, but if you understand where it comes from, it makes sense. All of that to say, when the unit circle rotates, we go that direction. We travel this way when we start our travel. So again, positive rotation mathematically. All right, that's all I got for unit circle. Any other questions about anything? Any other questions about life? Ellie?
How was your Father's Day?
Oh, it was great. So by the way, I do not have your chapters 5 or 6 graded yet. I was in Ironton for about a day and a half for my presentation last week. I went home for Father's Day, all that stuff. So I'm behind. I've not gotten to put in as much work as I should on this. So I will get those graded hopefully today or tomorrow and have them ready. If you're like dying to get your stuff graded, let me know and I'll bump it up to the top. Otherwise, I promise I will have it done by next week. Anything you turn in today, I'll also get graded by next week. This weekend I'm in town, I'm working, I'm not traveling. Yeah.
Where's Ironton?
Almost Kentucky. So it was I'm going to go ahead and stop this video. So if you're at home watching, we obviously didn't do much in class today. I might work one-on-one with people. But please stop in, turn in your assignments, take tests, pick up paperwork, whatever you need. Email me, text me. Please make sure you're getting done with your work. You should be on chapter 7 and 8. If you're not, you're behind. Thanks, guys.